David Gann here with another question from your Hayes & Harris Math SL textbook. This is Chapter 5B.2, Question 5A, B, and C. We're asked to sketch on the same axes the graphs of f of x and f of 2x for these three functions. So let's start with y equals x squared, which is our standard parabola. In our standard parabola, when x is 0, the 0 squared is 0. We go through the origin. When x is 1, 1 squared is 1. We go through the coordinate 1, 1, and negative 1, 1, because negative 1 squared is also 1. When x is 2, 2 squared is 4. So we go through 2, 4, and negative 2, 4. And when x is 3, 3 squared is 9. So 3, 9, 4, 16, 5, 25. You can see that the vertical component is growing faster than the horizontal component. And that's what gives us this parabolic shape. Okay, so this is f of x. Now I'm going to take this and copy it because I'm going to use it for parts B and C. But before I move on to parts B and C, let's look at what f of 2x is. Well, 2x in this function notation, what that's going to do is that's a horizontal stretch or squish. Multiplying by 2 is a squish by a factor 2. So if you imagine that this graph were printed on a rubber sheet, what I would do is I would put pressure on it from both sides and squish it until it's half its original width. So every point from the center moves in by half. We go out 1, but now we only go out 1/2. We go out 2, but now we only go out 1. We go out 3, but now we only go out 1.5. Same here, we get squished in, 1 becomes a half, 2 becomes 1, 3 becomes 1.5. And we see that we get the same shape, but it's narrower. We get a parabola again. That was a bad parabola. But it's narrower. And that's going to be f of 2x. Well, what if we have not x squared, but x take 1 squared? We still have a parabola, but it's not the exact same parabola. It's shifted horizontally by 1 unit. So let's grab the function and shift it in the positive direction 1 unit. Negative sign in here means shift in the positive direction. Then what we're going to do is we're going to squish it again. We're going to put pressure on the outsides and squish the graph. But we always squish not around its axis of symmetry, but around the y-axis. So this point stays where it is. This point moves in. 1 becomes a half. 2 becomes 1. 3 becomes 1.5. And 4 becomes 2. 1 becomes a half, and 2 becomes 1. And what we see is, again, a similar shape, again, a narrower parabola, but they no longer share a vertex. The vertexes have moved. The only point that they share is right here on the y-intercept. Same here, they only share the y-intercept. Or what about here? If we move, if we look at x plus 3 squared, this is also a horizontal shift, plus 3. It's a shift in the negative direction. So let's grab the function and shift it 1, 2, 3 units in the negative direction. That's about right. Okay, once again I'm going to put pressure on the sides and squish around the y-axis. So everything halves its distance from the y-axis. That one stays there. That one moves in. 1 becomes a half. 2 becomes 1. 3 becomes 1.5. 4 becomes 2. 5 becomes 2.5. And 6 becomes 3. And once again, I get that same narrow parabola, but also, oh, these are terrible parabolas today. But also the vertexes are in different places.